Hello students, welcome to CMIS online classes, and this video is for class 8 chapter number 13 and the name of the topic is sound. It is very interesting chapter, and previously in our classes we discussed about the source of sound, how sound is produced, and we also discussed about how human being produce sound with the help of voice box. Then we also discussed various structure of ears. Now today in this session we will talk about other forms of the chapter. So let's start. So first of all we will talk about vibration and oscillation. As we discussed earlier that vibration, due to vibration only sound is produced. Okay, so what is vibration? So vibration is the to and fro or back and forth motion of an object, and vibration is also called oscillatory motion. That means if this is a vibrating body, okay, if this is a vibrating body, think this pendulum as a string of a guitar, okay, and if we just touch the string, that is if we make it vibrate, so it vibrates like a pendulum. That means from point A to point O, then B and back again. Okay, so the motion of the pendulum from one extreme point to the other extreme position and back is called an oscillation. That means it oscillates. So when this bob from point A to B oscillates, this causes vibration. Okay, now we will move to another topic, frequency of sound wave or oscillation. Okay, so number of oscillation per second is called frequency. Okay, that means in a second when this oscillation increases, the vibration also increases. Okay, and in a second if this oscillation becomes slow, that means in 1 second if it oscillates only one time, it is slow, but if it oscillates 2 to 3 times, that means it is fast. So frequency is higher in that case. Okay, so the unit of frequency is hertz, or we can say hertz. Okay, so whatever the frequency is or the sound made by different things, okay, so they have certain units and that is called hertz. Okay, like 20 hertz, 60 hertz or 1000 hertz. Okay, so let's move to other, that is time period of sound wave. That means the time taken for one complete oscillation is called time period. That means from A to B and back again, that means one complete oscillation, and this is called time period of an vibration or oscillating body. The SI unit is second, okay, or S. If the duration is much more small, and if it is higher we can take minutes. Now let's move to other part, that is amplitude of sound wave. So what do you mean by amplitude? Let's see. The maximum displacement of an oscillating body from its central position is called its amplitude. That means from O to A or O to B. Okay, that means the distance between AO and or distance between OB. If the distance between AO is similar, as it is oscillating in a periodic motion, it takes same time to oscillate from point O to point B. Okay, so the amplitude of the sound wave is the highest of the crest or tuft. It is represented by letter A. Okay, the SI unit is the same as that of density or pressure. Okay, so we have a figure here. the wavelength figure, amplitude figure. If the amplitude is higher, the sound is also produced higher. Okay, now let's move to speed of the sound. Okay, so what do you mean by speed of the sound? That means whatever the things, if you have to travel from one place to another, it takes time and you require certain speed also. Okay, so sound to travel from any medium, it requires certain speed. So speed of the sound depends on the elasticity. The ability of an object or material to resume its normal shape after being stretched or compressed is called its elasticity. That means the vibrating body. Okay, as for example, as I am taking example of a guitar string. Okay, if we just touch it, it will vibrate, but when it comes to normal position, it is called, that is called its elasticity. Okay, so the density of the medium through which it propagates, that means through which it passes. So in case of air, it also depends upon the temperature of air. Okay, so we have different types of speed for different medium. Okay, so the speed of the sound through air is about 330 meter per second. Okay, it's 330 meter per second. That means if one has to speak from one point to another, and in 1 second the sound will travel at around 330 meter, then only one other person can hear the sound of the first person. Okay, the speed of the sound of water through water is about 1500 meter per second. That means 5 times more than the air. Similarly, the speed of the sound in iron and steel is about 5000 meter per second. That means in iron or steel, the sound travels faster. Okay, so sound travels faster in solid than in liquid than in gaseous state. That means the speed of the sound is least in gas. Okay, I will take an example. Okay. So 5000 meter is equal to 5 kilometer. So if you are in a railway station and if the train is coming from one direction and it is at about 5 kilometer apart, you can hear, if you put your ear on that track, you can hear the sound of the train. That means 5 kilometer, the train is 5 kilometer away from you, but also you can hear. That means it travels faster in iron and steel. Okay, so this was all about speed of a sound. Now let's move towards loud characteristics of sound. Okay, sound characteristics, that means features. So we have loudness and pitch. What do you mean by loudness of sound? The loudness of sound depends upon the amplitude of vibration. Okay, if the amplitude is less, the sound is feeble. That means of less means not, it is not loud. And if the amplitude is more, the sound is loud. That means loudness depends on the amplitude, and the unit of loudness is decibel. Okay, dB, decibel. So so let's take an example of a sound of a you can say of a grenade. Okay, explosive bomb. So it produces more sound, the sound is loud, so it has more decibel. You can say 100 decibel. Okay, and that is more harmful for our ear. Okay, in the same way, another topic is the pitch of the sound, which depends upon the frequency of vibration. Okay, which depends upon the frequency of vibration. Means loudness depends upon the amplitude and pitch depends upon the frequency. If the frequency is less, the sound is of low pitch. Low pitch means quite normal. Not, we can't differentiate low pitch, or we can't compare low pitch with loud or feeble. Low pitch means tikha. Okay, that means the sharpness of the sound. Okay, so sound of a drum, it's not that sharp. Okay, sound of an adult, okay, they have some harsh voice. Similarly, if the frequency is more, the sound has a high pitch. Okay, example, sound of a whistle, CT. Okay, it makes a sharp voice or sharp sound. Okay, similarly, sound of a baby. Babies also have sharp voice or sharp sound. Okay, so that depends on the pitch of the sound. So we talked about loudness and pitch of a sound, and these two helps to for producing good quality of sound. Okay, if these two are in a normal condition, that means loudness and pitch, the quality of the sound becomes good. Now let's move to another part, and that is audible and inaudible sound. What are audible and inaudible sound? Okay, so we have two types of sound. Number one, audible, which we can hear. That means which we can hear. Okay, and it has a frequency of between 20 hertz to 20,000 hertz. Below that also we can't hear, and above 20,000 hertz also we can't hear. That is inaudible sound. And those sound, that means below 20 hertz and above 20,000 hertz, mostly animals can hear. Okay, that means dog and bats, they can hear the inaudible sound. So we will move towards range of hearing. Human can hear sound frequencies between 20 hertz to 20,000 hertz. Okay, so sound whose frequency is less than 20 hertz is called infrasonic sound. Animals like dog, elephants, rhinoceros, whales produce and hear infrasonic sound. That means below 20 hertz, and above 20,000 hertz are called ultrasonic sound. Okay, that means bats and dolphins, they can produce and hear ultrasonic sound. So these are all about the ranges of hearing. Now we will move towards noise and musical sound. What do you mean by noise? Unpleasant sound are called noise. And what causes this unpleasantness? It is due to irregular or non-periodic vibration. Okay, that means the frequency. Okay, the frequency or the amplitude. If it is mixed, the sound is unpleasant. It becomes noise. As for example, in a classroom only, if we ask one student to sing, he or she can sing well. Okay, means it will be good to hear. But if all of you start singing at once, the amplitude frequency will mix up, and that is the reason noise is produced. Okay, so sound produced by horns of buses and trucks also are unpleasant, and these are called noise. And the second hand, we have musical sound. Sound which is pleasing to ears, or it's pleasant to hear, is called musical sound. And these sounds are regular or periodic vibration, or in periodic vibration. That means the amplitude frequencies are correct in a uniform motion. Okay, so example, sound produced by musical instrument and sound of a person singing a song, or we can say sound of a singing bird. Okay, it is pleasant to hear. Okay, so this was all about noise and musical sound. That means sound pleasant to hear. Now we will move towards noise pollution. As we all know, when sound that is excess or unpleasant, okay, or unwanted sound that irritates us, and that which makes the environment unpleasant, are called noise pollution. That means the presence of excessive or unwanted sound in the environment is called noise pollution. Okay, as for example, sound of loudspeakers, okay, they are quite loud and unpleasant to hear. Okay, so let's talk about its causes. So noise pollution is caused by sound of vehicles, explosions, bursting of crackers, machines, okay, even the home appliances like television, radio and music system at your home. Okay, if the volume is higher, it causes noise, okay, and hence produced noise pollution. So harmful effect of noise pollution, what are its harm? So noise pollution causes several health related problems like lack of sleep, okay, hypertension, high blood pressure, anxiety, etc. Or it also causes temporary or permanent impairment of hearing. That means they become deaf. Okay, the person will be deaf. And we can have an example in around also. If you see a sick person or a very old person, okay, so when a loud music is produced, okay, now noise is produced, okay, their heart starts beating fastly, okay, they become irritating. So that is the reason why they are more sensitive. Okay, so that is all because of noise pollution. Now let's talk about the third point, that means measure to limit noise pollution. How we can reduce noise pollution? So there are various ways. So reduce by using silencer in vehicles, industrial machines and home appliances also. Okay, that means using silencer, and less use of vehicle horns in the traffic or in the highways or in residential areas. Okay, even TV, radio and music system can be run at low volumes, that can limit noise pollution. Another one is planting of trees along roads and buildings. Okay, that also helps to reduce noise pollution because it forms or it acts as a barrier between the noise. Okay, now we will move towards some figures which produce noise pollution. Okay, uh, big musical instruments, loudspeakers, firecrackers, okay, even we have explosions, then festivals, big machineries, etc. Okay, so what all these causes? These causes, as already discussed, hearing loss, also known as hearing impairment, is a partial or totally inability to hear. That means a person can't hear anything. Okay, his eardrum or the receiving organs has been damaged due to loud sound. Okay, a deaf person has little to no hearing. Okay, partial disability is generally the result of disease, injury or age. Okay, that means due to disease, injury, that means some may just put something in his ear and it can cause injury. Okay, or age, with age also the hearing ability will be reduced. So this was all about the chapter sound. Thank you.